When you're starting your final project and looking through your data for interesting or useful graphs and observations, the first thing I would do is just start making graphs. So I'm using the movie data here to show what I mean. I'm going to just start with the beginning of the course and put in a variable like studio to begin with, and then I'm going to choose a quantitative variable like domestic sales or domestic opening weekend, pardon me. I'm going to make that look like the kind of graphs we've looked at in the past. And so the first thing I notice is, of course, there's lots more Big Six movies, and I can even put that number in if I like. But then I also kind of notice that the mean of their domestic opening weekend appears to be similar. Maybe it's a little higher for Big Six. And since these are pretty close to symmetric, I'm going to go ahead and put the mean in, and notice that I get something that's a little bit bigger, but not that much bigger. If I want to compare that using my standard deviations, I'm going to see that I've got a lot of overlap in the typical area or typical region. So what I'm seeing now, you might say, is, well, they're not very different. I don't think that's a big deal. But actually, it kind of is a big deal because it shows they're not very different. In other words, even though these are the Big Six studios and these are the more independent other studios, their actual amount of money they make in their opening weekend is not that different, which means that the other studios are really about as successful in terms of opening weekend as the Big Six studios. So that's an example of something you might notice. We could also, try another variable here. You just fooling around. You'll notice there's a little more difference when I put in the star race on the vertical axis here, and see that there's actually a bigger difference in domestic opening weekend, although of course there's not very many people of color in starring roles in these movies. If I look for genre, again we see a little bit bigger difference, although still quite a lot of overlap in the typical areas. So you're just looking for these kinds of differences or similarities between the different variables. So another kind of graph that you might be looking for is, let's look at budget compared to this. So now we're going to put in and make a scatter plot, and I'm going to get rid of these things that we don't use in a scatter plot. Oh, and look at this. We see, as you might expect, a positive, reasonably linear, not very strong correlation between the domestic opening weekend and the budget. If you're like, wait, no, I want the budget to be explanatory, I'll swap those axes and make it this way. So the point here is that I'm just looking for different patterns and different kinds of variables. I could try something else like, well, let's compare budget to IMDb rating. And here I see basically no correlation. This is pretty close to a 0 in terms of correlation coefficient. And you really maybe you see a slight upward or slight positive direction, but it's very weak. And I would say basically no correlation between these two variables. You keep on trying. How about Oscar nominations and budget? Again, you're not seeing too much there in terms of correlation. And maybe you try Oscar nominations with IMDb score. Maybe a positive curvilinear correlation, but not too strong anyway. So here I am trying those kinds of, I just look around looking for different correlations. And by the way, no correlation is an observation just as much as correlation is an observation. So the fact that, for example, if I go backwards here, that there was no correlation between the budget and the Oscar nominations is important, because sometimes we think, oh, the movies that spend the most money get the most Oscar nominations, but that's not what this is necessarily showing. You've got lots of movies here in the moderate range in terms of budget that end up with lots of nominations, and also with not very many nominations. So it's important to notice both the correlations and the non-correlations. Try one more kind of graph. Let's just say we put in something like, oh, I don't know what this one is. Director race. Okay, we don't have very many people of color in the movie industry, as we know, but we can compare that with, say, star race and see if there's a relationship between star race and the director. In other words, are, say, white directors more likely to put white people in their movies, or are people of color directors more likely to put people of color directors in their movies? So what we see here is, and let's put in, I'm going to make director race my explanatory variable. If I put in row percentages, what I see here is that, at least according to this, it's not a very big sample, but people of color directors, 12% of them had a person of color in their starring in their movie, compared to only 4% for white directors. So it does look like people of color directors are slightly more likely, a little more likely to have a person of color star in their movie. Not that surprising. Let's look at what about co-star gender. Just poking around here. Oh, look at this. So now white directors appear to have a more chance of having a female co-star in their movies as opposed to person of color directors. Let's look over here. I keep messing around here. Big studio, Big Six studio, 37% had a female co-star in them, and 42% of other had a female co-star. So we're seeing that's actually not much of a correlation, because those two are very close to each other. So it doesn't appear to make a big difference what kind of studio you're in, but the type of, or the gender of the co-star is not going to change that much. So this is the kind of poking around, looking for different relationships or non-relationships that you can find, and I hope that's helpful as you get started. Thanks.